Okay, so my name is Sunny. It's in my notes. I work at Grasshopper Asia. It's a high frequency trading firm. So think investments at smaller scales, right? So I'm a software engineer with them. Currently, I'm building JavaScript powered platforms for traders to make quick trades. Okay, so before I move forward, so today I'll be talking to you about protocol buffers. It's a way of serializing data when you want to send across the wire. But before I get that, I think that I like this concept of meta learning, where in the subject that you're going to learn, there are some other nuances that you can pick up. And one of that is, today's meta learning would be, there's no best. Okay, when I talk to you about protocol buffers, most of you might think, oh, this might be the best thing, or this might not be the best thing. JSON might be the best thing, right? That's not the case because you always have to approach it in a very objective manner. So when you want to decide whether you want to use this, you find out what your requirements are, and then match it against, benchmark what your current status is, match it against what's happening, and then decide whether you want to move forward with it. In this case, you're talking about protocol buffers, you're talking about transmission of data over a network or storage. So you would be, oh, what's my file size? Or how fast does this transmit? Those questions need to be answered first, yeah? So moving forward. Okay, so it's a way, protocol buffers, it's by Google. It's a way of serializing data for storage or for transmission over a network, yeah? The way it does this is that it converts it into binary format, and then it streams across whatever platforms you have. One of the very common other ways is JSON and XML. I'm sure most of you know about it, right? How many of you know about protocol buffers? Fantastic, nice. Okay, yeah, so we've been using this quite extensively at my firm. So like I said, it's by the guys at Google. They've been working on it quite extensively as well. It's an open source project. The next few things is it's platform agnostic, meaning I could have a Node.js server or a Go server talking to a Android device or a Swift, a iOS device, right? So you can transmit data in a very fixed format over the network. And deserialization and serialization, everybody knows what that is, right? Anybody does not? Okay, happens through various APIs that they have available in multiple different languages. So you can talk about Python, JavaScript, C++, Ruby, right? So now that you know what protocol buffers are, let's try and take a look at what it is, what it looks like. Okay, so to get started, right, you would need to have three things. One is generated, two are required. So first you have your proto file. Think of it as your schema, right? If you look at it carefully, it's quite easy to understand, right? Syntax just means that I'm using protobuf version 3. Yeah, and then here I'm describing an enum to say that there are three types of phone numbers, right? And then everything is a message, as you can see, right? And for example, the phone number, I would like to say that a number is a string, and I'll tag it to 1. Now this is why protobufs are very, very powerful, because they do not collect metadata like JSON does, right? They identify via this number here. Right, so converting into bytes would be a lot more faster. You can compress data, make it more dense as you transmit over the wire. Yeah? You can also have collections in the same struct where you say it's a repeated field, so I can have multiple phone numbers called phone, and I'll tag it to 4. I will not go into depth about the technicalities. You can easily read them up. For me, it's just tell you more about what this is. Yeah? Okay, so next, once you have your proto file, you'd have a compiler, right? It's called the protoc-c. What we do with that is to say, here's my proto file. I need it to be compatible on my C++ platform, right? So it compiles, it outputs an API that you can use to access, to deserialize and serialize data that you want to transmit over the network. Yeah? So other generated APIs include like C++, C#, Ruby, Python. The one I have here is our JavaScript output format. So as you can see, for phone number, you can set the number or you can get it, right? The API is a lot more extensive than this. It's a lot more powerful. I'm just giving you a small snippet of it. Yeah? Okay, so what happens is that usually you would have one copy of this, you'd compile out 2 versions and then put it on each server or client that you have, right? And then I'll explain more about some of the nuances that you might want to observe. Okay. So because of the other API formats, you don't need to worry about whether your platform is on one language or one platform. All of that does not matter. Next. This is a bit complex, so I will try and take it slow. Okay, so the workflow is this. Let's say you have a Go service, and you want to transmit stuff to a client further down the line, right? One of the things is that your Go service will call an API, the Go API, which will then serialize it into whatever format. Points for whoever can figure out what that is. And then it transmits over the wire, okay? Hits whatever Node.js server or any other microservice that you might have. And this is where protobufs are most powerful, right? This packing that they do here is very dense in the sense that it's small file transmitted quickly over the network. Yeah? So a microservices architecture would best benefit from this. And I'll tell you more about when it does not benefit. Okay, so Node.js server gets it, calls the API, deserializes into JavaScript objects, does what it needs to do, serializes it into JSON, and then transmits to the client. So some of you might be thinking, this is very inefficient. You're like converting from one format to another. Like I said, only when you have microservices architectures, then this would matter to you. Yeah? Okay. So now that you know what the flow is like, I'm going to quickly move on to my most important things. Do not use it if. Okay? 1. Your data is directly consumed by the browser. JavaScript is fantastic. Our browsers are very powerful, right? So do not use it if you're talking to a browser because browsers use JSON very well. They're optimized, right? So stick with JSON, yeah? Okay, next is JavaScript. Like I said, if your architecture is largely JavaScript, JSON is already the best thing you can do. Native binding is very powerful in JavaScript and your browsers. Next, your large packet sizes. So protobuf excels in a very specific file size. If you hit above 1 MB, then you need to rethink your architecture, right? If you're transmitting more than 1 MB of data per packet. And if it's below 300 KB, then when you gzip your JSON versus your protobuf, right, they're almost the same. So the packing is something that you need to think about. Yeah? A lot of people will show you benchmarks, will be like, oh, JSON is far faster, or protobuf is far faster. That is their scenario, it's not yours. So remember, the only thing I would like you all to take away from this is follow your own context first, and then do your tests. So yeah, large packet sizes. This is also very important. Young startups, some of you might have your own projects that you're working on and you want to build a business. Do not use protobuf. Okay, do not waste time in trying to implement it because JSON will get your job done quickly. You want to understand your data structure. You want to understand how you use it. Where are the less optimal areas? Identify those things. And then when you look at scaling, you will do it. So the meta learning here is premature optimization is stupid. Yeah? So remember that. Okay, so when should I use it? Okay, wait. Okay, yes. If you have a Node.js server that's talking to native Android apps or Swift apps, because you're no longer using the browser, right? So parsing JSON files might not be as optimal as you might like it to be, but protobuf is quite optimal in that sense. Yeah. So it might be a good idea if you have a Node.js server that's talking to some application outside of the browser. Yes, microservice architecture spanning multiple languages. So that's the case in my firm, right? We've got various languages all talking to one another. Our output is on a browser. So in between each service, the communication protocol is protobuf. Yeah. So things like protobuf performance is far better on Java platforms, right? As compared to JSON performance. So if you're building for a Java output, your client, then you might want to look at that. And this also helps us because having a strict schema prevents a lot of stupid behavior when someone decides to typecast into something else and sends it over the wire to you. Yeah? So you might help you in that sense. and high data throughput. So this is where it's interesting because remember how previously I said if you have a largely JavaScript architecture, do not do it? This is the only exclusion that you might have if you have high data throughput. Because compared to XML and JSON files, XML is strictly, protobuf is about 3 to 10 times smaller and about 20 to 100 times faster in transmission. So it might make sense, right? If you are a company moving at scale, you're making a lot of calls, or you are using WebSockets to send packets over consistently, then you might want to look into it. Yeah, but always test first if you save, because some people, we tried using protobuf's gzip versus JSON gzip. Difference about 30 KB. Doesn't matter unless you move at a very large scale. Yeah. So that's about it. So that's my presentation. So I hope it helps you all understand a bit more. If there's one thing that I wanted you all to take away from that was to figure out, yeah, that's all my slides. Was that there's no best. Try and do a contextual test first before you move forward. Any questions? Yes?
High throughput, do you mean the high frequency? Because you said size.
Correct. Okay. So for us, in my firm, we are talking about maybe hundreds of thousands of packets of information coming through the wire. So when I say high throughput, I'm talking about a lot of packets coming in and moving out, right?
Packet size.
Yeah. Because if you have high throughput plus large packet sizes, then there might be something wrong with your architecture, right? So you need to rethink that, cut it down to smaller pieces, and send them more frequently. Then you might want to use protobufs. But if you have no choice, then do not use protobuf because it's not as optimal as you want it to be. Any other questions? Yes?
You need the same proto file to be
Yeah.
the client and the server, right?
Okay.
If you have, let's say, a version of
Mm.
protocol,
Correct.
how do you handle it?
Okay, so one of the interesting things, I didn't discuss this, was the version control in protobuf. Let me just come back to the slides. So this tagging, right? One thing is that there's backward compatibility in here. So I could say that I have a new type, or let's say a new way of describing emails, right? I could easily put email new and then put for. So services that require normal emails, they could access this, and services that do not require can just skip through it and then parse the other ones, right? That's one. So that's version controlling. It has some capabilities in there. If you talk about changes in schema, right? For us, the way we maintain it is that we keep this in one repository, and always when there's a change, we recompile to get it out there. This does not need to reside in the server. This can reside outside of the server. This is what needs to reside in your servers for it to work. So this is an input of sorts. Hits the compiler. Compiler generates this for you to use it on your server to serialize and deserialize.
But you need the same version on both the client and
Correct. So if you have the same version, you will definitely need the same version as with JSON even, right? When you deserialize, you are looking at whether the fields are all the same, right? And at the moment it hits something that it does not recognize, it throws you an error. So yes, you will need the same versions on both ends. Technically it's one, because it's only one input file, right? So it's only one master copy that you modify, but you recompile into various APIs that might have the updated copies. Yeah, I hope it answers your question.
it's just that it makes it more complicated.
Correct.
If you have a mass deployment files.
Correct. So that's why I would advise people who do not really have a very distributed architecture to use this, right? Do not try and do this because it's a lot more harder to maintain, right? But the moment you move at scale, this might be worth the effort that you have in terms of cost saving in bandwidth and speed. Yeah. Anything else?
We have time for another question if anyone wants to ask.
So who has used protobufs? Okay, can hear it from them. I have a question. What's the biggest problem you faced?
Serialization time.
Right, okay.
used it on a browser for a game, and it used a lot of CPU to deserialize. I needed to put it in a web worker.
Correct. So as you can see, like I said, right, do not use this as a transmission protocol to hit your browsers. Always keep it in your servers, right? And hence the suggested architecture where you want to deserialize in your servers and then push it out as JSONs, because JavaScript very well, does it very well. Parses JSON objects very well. Yeah? Anybody else has issues that they want to highlight about protobuf? Okay. So that is about it. Cool. Thank you.